Hello friend, this is Sahil Kamboj and welcome to my YouTube channel Data Science Story. In the previous video, we have learned about what is machine learning and what are the types of machine learning. And in this video, we are going to learn what's the difference between supervised learning and unsupervised learning, and further what are its different subgroups. So let's get started. So first basically we'll see what is supervised learning. As we have learned earlier that it is the learning in which we have the output variable. Okay, so the supervised learning is also further divided into two sub problems. It is regression problem or classification problem. So from my experience, I am going to tell you one thing, that whenever you get a business problem from your client, the very first basic steps that you are going to see in the problem, that whether it belongs to a regression problem or a classification problem, if it is supervised problem. Okay, so what is regression problem? In regression problem, we are going to predict or estimate a continuous output value. So what's the continuous output value? Continuous output values are like that have continuous values like 1, 1.2, 1.3, 1.4, 1.8 like this. Okay, so and I'm going to tell you the examples of some regression problems like house price prediction, or predicting the price of mobile, or predicting the wage of a person depending upon the different attributes of that given person. And apart from this, there is another different subclass of supervised learning, that is classification learning. In classification, what we do is we predict or estimate a categorical value. And what is categorical value? A categorical value or output is that output in which we can categorize our output target. Like for example, it may be that a person may have a particular disease or not, or he may not have that particular disease. And the classification problem further divides into two subclasses. One is binary classification and other is multi-class classification problem. As you get the idea from its very name, in binary classification problem you have only two categories that you are going to predict or estimate, and in multi-class classification problem you have more than two categories that you are going to predict. And some of the examples of classification problems are like you are supposed to predict whether a particular transaction is fraud or not, or you are supposed to predict the performance rating of employees of a company. And this problem of predicting the performance rating of the company can be a classic example of a multi-class problem. In performance rating, you may have more than two type of categories that you want to predict. From the previous video, we have learned that in unsupervised learning, we have the input variables but don't have the output variables. Let me give you one example, and from that example it's gonna be very much clear. So in unsupervised learning, what we do is we try to analyze from the given data what are the relationships are present in that particular data. Okay, suppose you have a company and you sell a particular product, and you also have a demographic information of your customers or potential customers. So you want to understand which type of customers are similar to each other by grouping them into different clusters, and this is also called a cluster problem. Okay, and in another example, suppose you have a gene expression data, and in that data you have a gene expression of number of cells, and by analyzing those gene expressions you want to cluster those cells into number of different clusters. And unsupervised learning, also called a clustering problem. In the right hand side of your screen you can easily see that the gene expression data, and in that, by analyzing the gene expressions of n number of cells, we successfully able to categorize those into different type of groups like red, dark blue and green. Thank you guys, that's all for this video. Hope you enjoyed this video, and we will meet in next video soon. Thank you very much.